Hi everyone, my name is Chiamaka Osuagwu, and this presentation was prepared for ACN 6375, Mapping of the Spinal Cord with Dr. Faisal Jahangiri. In this video, I'll be walking you through the 1020 electrode placement system, which is the standardized method used to ensure consistent and accurate recordings of brain activity. So developed in the late 1950s by Herbert Jasper and his colleagues, the 1020 system is designed to standardize how electrodes are placed on the scalp, making EEG recordings reproducible between different patients and researchers. It relies on anatomical landmarks and proportional distances across the head, meaning it works for all head sizes and shapes. And this system helps us accurately capture brain activity from specific cortical regions while keeping measurements consistent across labs and sessions. So first things first is electrode naming. So each electrode is named according to the brain region it records from. So the letters indicate the general area. F for frontal, T for temporal, C for central, P for parietal, and O for occipital. So something a little unique is that we have the FP electrodes or prefrontal electrodes, and those just sit just above the forehead. And then it's important to note that even though there's no central lobe in the brain, the central electrodes are key reference points because they pick up activity from overlapping frontal, parietal, and temporal areas. Okay, so before measuring, we need to locate four key landmarks. So we have the nasion, which is that dip between the forehead and the bridge of the nose. We have the inion, which is the bump at the lower back of the skull. And then we have the left and right preauricular points, which are just above each ear canal. And I might interchange preauricular with ear-to-ear points, but it's the same thing. And then we have the vertex or CZ, that's somewhere right here. And that's just a true midpoint between front to back and ear to ear lines. And these points form the foundation for all our electrode measurements. Okay, so first we have the numbering system, which is it follows a pretty simple rule. So odd numbers are on the left hemisphere, and then even numbers are on the right. So for example, F3 is on the left frontal area, while F4 is its mirror on the right frontal area. And this mirrored numbering helps us interpret lateralized brain activity, such as when we're comparing left versus right hemisphere responses. Okay, so now for our electrodes with a Z. So these are the ones here, such as FPZ, FC, CZ, PZ, and OZ. So all these lie along the midline of the skull. And the Z stands for 0, and it represents no left or right bias. So essentially that's saying that there's like minimal lateralization on this line. So these electrodes capture signals from both hemispheres equally and reflect activity across the sagittal midline, especially over the corpus callosum. Okay, so let's imagine that we're measuring electrode positions on a giant with a perfectly spherical head and a nasion to inion distance of 100 centimeters, and therefore, since it's perfectly spherical, ear to ear distance of 100 centimeters. So first we start by measuring straight over the top of the head from the nasion to the inion. And the FPZ mark, this one right here, would go 10 centimeters from the nasion. And 10 centimeters is because it's 10%. It's 10% of the total distance from the nasion to the inion. And in that case, that's 10 centimeters. Will get us our FPZ. And the OZ mark is 10 centimeters from the inion, in this case 10, and so 10% from the inion, or 90% or 90 centimeters from the nasion. So between those 2 points, so once we've taken those 2 points, we divide the remaining 80 centimeters, or 80% of the total distance, into 4 equal 20 centimeter segments. And these give us FZ at 30 centimeters, or 30% of the total nasion to inion length, CZ at 50 centimeters, and PZ at 70 centimeters. So this is why it's called the 10-20 system, because it is the 10-20-20-20-20-10 pattern that keeps all our placements proportional. Okay, and this is just a different representation, a different viewpoint of it. Okay, so now for our ear-to-ear measurements. So if our giant's preauricular distance is also 100 centimeters, we're going to place T3 and T4 at 10 centimeters, or 10% of the total distance from each ear. So from here to here is at 10% of the total distance, and then from here to here is 10% of the total distance. And our model of 100, it's going to be 10 centimeters. Now, C3 and C4 are going to be another 20 centimeters inward, or 20%, and then CZ is right at the center at 50 centimeters of that 50 centimeters, or 50% of that total distance. So this line, T3, C3, CZ, C4, and T4, they represent the lateral axis and ensure symmetry between hemispheres. Okay, so next we measure the skull's circumference. So what we want to do is we want to measure just above the ears, across the forehead, and around the back. So for a 100 centimeter giant head, the pattern divides the circle proportionally. Now this one is a little different because this is a development to the 1020 system, and it's a specialized version called the 510 system, and this is specifically for our skull circumference because instead of that 1020 pattern, we're doing a 510 pattern. So on the right side, we'd have FP2 at 5 centimeters from our FPZ point. F8, 15 centimeters, T4 at 25 centimeters, T6 at 35, and O2 at 45 centimeters. So those are also the same percentages, 5%, an additional 10%, so on and so forth. And the left hemisphere mirrors this layout. So FP1 is at 5 centimeters, or 5% from that distance, and pretty much the same pattern we did here, we're going to do there as well to get all of our points around here. So this completes the outer electrode ring. Okay, so for measuring F3, F4, P3, and P4, there are 3 accepted measurement approaches, and each is based on the same proportional logic, but along different axes. So in the front to back method, we measure from FP1 or FP2 to O1 or O2 respectively, and F3 and F4 lie 25% of that distance. So this distance here from FP1 to O1 and FP2 to O2. So they lie 25% of that distance back from the front. And then P3 and P4 lie 25% forward from the back. So from here to here would be 25% of that total distance. And then from here to here, we also have 25% of that total distance would get us P4, and 25% of that total distance this way would get us F4. And then finally, we have the side-to-side method. In this case, we measure from our side electrodes. So we measure from F7 to F8 to find F3 and F4. And then we measure from T5 to T6 to find P3 and P4. And essentially the total distance for each, so the total distance from here and the total distance from here, will be the basis of our percentages. So F3 and F4 are 25% up from F7 and F8 towards FZ. And P3 and P4 are 25% up from T5 and T6 towards PZ. And now finally, we have the diagonal method. And this is measured from the Nasion to the inion, but not through our midline, but rather through C3 and C4. So we're actually measuring it kind of diagonally like this. And the F3 and F4 points are 20% of that total Nasion to inion length in front of our central electrode. So from here to here, it's going to be 20% of our total Nasion to inion length. And then P3 and P4 are 20% behind them. So it's important to note that each method will give a slightly different nominal coordinates, but all preserve the same proportional spacing defined by the 1020 rule. So in our case of our 100 centimeter giant head, this means each 10% interval equals 10 centimeters. Okay, so this is just the references. principles of this presentation came from Jasper's 1958 EEG standardization report. And in addition to that, I've also used modern guides by Valentine as well as Dr. Jahangiri's lectures. So the images were created using Canva and resources from Brigham and Women's Hospital. So that is my presentation on the 10-20 system. I hope it was helpful, and thank you.